Welcome friends, welcome back to our channel Crystal Learning. So today there is a thumbnail, you have seen the thumbnail, this is the thumbnail. So here I am not here to create any controversy, just I am here today not as a faculty, as a student, because there are some doubts which I was not able to solve, because this question came in GATE and they have given the video solution also and the answer key also. So according to that, the answer and the concept which I read in the book, standard book, the concepts are different and the answer is not matching accordingly. So there is a humble request to all of you who are watching this lecture and they are studying in engineering colleges, in NITs, IITs or in any other colleges, or they are studying in the coaching, different coachings. Please discuss with your teacher, and if you will provide me with the right concept that which one is right, I will be grateful to you. So I am just waiting for your answers and your concept, and please justify your concept through the reference of any standard books, because many times it is seen that the teachers or faculties are giving wrong concept or wrong answers, but in books are different, and sometimes it is seen vice versa, that in the concept given in the book is wrong, but the concept given by the teacher and faculty is right. So there is a confusion between this, because only one will be right. Okay, so I am waiting for your answers, and please spread this video through your friend circles and others to get the right answer. So let's see the question. So this question came in manufacturing process and GATE Metallurgical Engineer 2017. So this question says a material which shows power law behavior sigma bar equal to 50 times epsilon bar 0.3 is being wire drawn. The maximum strain per pass in annealed condition, assume idle work and efficiency neta equal to 1 is. Okay, so here it is asking maximum strain per pass in the annealed condition, the bone of contention. The doubt comes here because of this annealed condition. If it was not written, then no doubt. Okay, no doubt. But it is here written here annealed condition. So we will see what is happening because of annealed condition. So before that, answer key was given between 1.20 to 1.40. So we are in place challenging the answer key, or we are trying to discuss that what must be the right concept. So the reference, I am giving the reference of the standard book, because of which the doubt came in my mind. So this book is William F. Hosford and Robert M. Cadell, Metal Forming Mechanics and Metallurgy, Cambridge University Press publication, published in 2011. Page number is 35 and page number is 79. On that you will get the concept. So before starting the concept, let's study some theory. So first we will see what is unstable plastic deformation. This is the stress strain diagram, we all know. So after yielding, there is a point ultimate tensile strain and then fracture. So this range is known as uniform plastic, written uniform plastic deformation, and this zone is known as non-uniform deformation zone. And here the necking starts. Okay, this is the point, maximum ultimate point where necking starts. After that, non-uniform deformation starts. So this is the stress strain diagram. A naught is initial cross sectional area, P is the load. So this load will be changing. So we have to know that what is the maximum load at that point. Okay. So this condition is identified on stress strain curve, that is maximum load point, by attainment of maximum value of P by A naught. That is the maximum load. And this condition of maximum load is utilized to determine the limiting condition in some applications involving tensile plastic deformation, such as wire drawing, because we are giving tensile load and it is plastically deforming, such as stretching operation and pressurized containers. So this maximum load point, we have to see what is the condition of that. So we will derive the condition of necking of a tensile bar. So what is necking? The point of maximum load in simple tension is commonly associated with initiation of non-uniform strain. At that point, non-uniform strain will start, or onset of necking. Necking will start from that point, or strain localization will be there. So that point of maximum load we have to find. So here we are giving that in terms of true stress, just keep a bar here. In terms of true stress and true strain, the current value of applied load F will be sigma into A. So sigma bar is the true stress and A is the current cross sectional area, not the original, because we are dealing with true stress. So this is the value given. So we know we have to get the maximum f value. So for maximizing this function f, we have to differentiate this function and put it to 0. So we are partially differentiating this function. So this will be df equal to sigma bar dA plus a d sigma bar equal to 0. So by recalling that two plastic strain increment in simple tension is defined by view of consistency of volume. That means in plastic deformation after yield stress, volume remains constant, that is V initial equal to V final. That means area initial, length initial equal to area final and length initial. Means they are inversely proportional. Means one will increase, other will decrease. Okay, two terms are there, area and length. Keeping that thing in mind, d epsilon bar is given by change in length upon origin, that current length equal to minus of dA by A, and this negative sign indicate that as length increases then area decreases. Okay, that minus sign is there. So rearranging first term we are rearranging. This is given d epsilon bar upon epsilon bar equal to minus dA by A, because it will go to that side, then it will become minus sign, or d epsilon bar, that sigma bar upon sigma bar equal to, because this term is equal to d epsilon bar. So we got this, and finally we will getting that is sigma bar equal to d of sigma bar upon d of epsilon bar. So this is condition of maximum load. At maximum load this condition is true. Okay, so we reached here. Let's go ahead. Strain hardening behavior is given by simple power law, that is sigma bar equal to k times epsilon bar to the power n. Okay, third equation. Here k is strain coefficient and n is work hardening, strain hardening rate. So differentiating this power law, now we will differentiate this power law. K is constant, so it will remain outside of the differentiation. Epsilon bar n will come to this side n times, then epsilon bar n minus 1. Okay, so we reached here. From 2 and 4, from 2 and 4 we see that sigma bar is equal to this term and this term is equal to this n times this. So we will equate finally sigma bar equal to n k epsilon bar n minus 1. So we can write this as n k epsilon bar to the power n upon sigma bar or epsilon bar. So this is n minus 1. So this term is equal to sigma bar. So finally we reached here. And now it is saying that this sigma bar equal to n times sigma bar upon epsilon bar. This term will be equal only when this has to be true. Therefore sigma bar epsilon bar equal to n. This is very important relation at maximum load condition. Okay, maximum load condition, this epsilon bar equal to n. So we know that at this point strain ceases to be uniform, that after this point strain won't remain uniform. Okay, and tends to localize at some point leading to necking, and this will lead to necking. So onset of necking occurs at a uniform strain, where that necking will start at epsilon, when this epsilon will reach the value of n, work hardening rate. So thus maximum load in simple tension, that is point defined by ultimate tensile strain, and necking is observed. Where it will observe, where you will get this point, when true strain becomes equal to strain hardening exponent. Okay, so you can also say that is maximum strain equal to this. So then the true stress of maximum load can be expressed as sigma u ultimate point equal to k times epsilon, and we know this from the flow stress of work, that power law, and that will be equal to k times, now epsilon you have to put n, work handling, that is n to the power n. So this is very much important relation, that is the bone of contention, and it is true. You can find this in every book which you read. Okay, so now let's move ahead. So now it is saying maximum drawing reduction. In drawing we get maximum plastic deformation and very negligible elastic deformation is there, and a power law hardening equation is given, that is true stress and true strain relation, that is sigma bar equal to k times epsilon bar to the power n, where sigma bar is true flow stress after yielding and epsilon bar is true strain, k is strain coefficient, and is strain hardening exponent. Okay, so now we will be calculating that what is drawing stress. Okay, drawing stress is given by sigma d 1 upon epsilon term neta integration of sigma bar d epsilon bar. This formula is given by Gate Authority and also book. There is no problem in this. So we will integrate this term. So by integration, k is constant, it will come outside, epsilon bar to the power n will be n plus 1 divided by n plus 1. So we reached here, that is sigma d equal to this. Another important equation. Now for drawing, there is a maximum possible reduction per pass, because you there won't be infinite reduction. There is a point that restrict the reduction of this wire. So that will depend on what? That will depend upon the strength of the material. That what is the strength of material? Maximum stress what a material can handle. So just read out this sentence again. For drawing there is maximum possible reduction per pass because the drawing stress cannot exceed the strength of the drawn wire material. So whatever the drawing stress we will be giving, that won't exceed the strength of the material. Otherwise, fracture will be there. So that is the maximum limit up to which we can uh, keep that drawing stress. Okay, for getting maximum possible reduction. So this line is clear. Let's move ahead. So then the maximum reduction corresponds to where sigma d equal to sigma that bar or ultimate point. Okay, set sigma bar. So in this condition, sigma bar is given that k times epsilon to the power n. So we will just equate these 2 points, keeping now that strain we are assuming that is maximum strain or limiting strain per pass. So we are just equating this k epsilon bar to the power n, k epsilon bar to the power n plus 1, and this we will rearrange them, and this is the maximum famous maximum strain per pass relation. Okay, no problem in that, and we have seen the derivation also. Okay, so according to this and the data given in the question, that is sigma bar equal to 50 times epsilon bar to the power 0.3, n is 0.3, and this neta term is equal to 1 given in the question only, so no need to worry for that. So according to this formula, here you just write equation A. Okay, so here we see 1, then bracket 0.3 plus 1, so it is 1.3 according to gate answer key and explanation also. So no point of confusion till now. But let's now come to the bone of contention, that is challenge latent point. What was the challenge latent point? It is asking maximum strain per pass in annealed condition. If annealed condition was not there, there was no doubt, no problem, absolutely right. But here it is again and again asking, just read that question again and again. So according to the reference, maximum strain per pass in annealed condition will be different, and how it will be different we will read now. So it is saying that book, this sentence is exactly copied from there. I have given the reference also. For all condition strain hardening rules and efficiency, the maximum drawing strain correspond to sigma d equal to sigma bar upon n. You can see this graph also. This graph is true stress. Okay, and this drawing stress graph will be like this. The intersection point will be the limiting point. Okay, so you see the maximum strain you will be getting when n equal to that efficiency term equal to 1, and others will be smaller. So this is for all other conditions. Okay, but now just read out this line. The conditions are different at initial startup, means when you are initially starting before the drawing. So undrawn material must be fed through the die, because we know that intermediate annealing is performed, but here it is not saying about intermediate annealing, that before drawing, when you are feeding the material in the die, then only if it is annealed, then the maximum drawing force will be correspond to tensile strength. It will directly correspond to tensile. This exact line is written. So now what we will do, that sigma d max equal to epsilon bar equal to sigma u equal to k times n to the power 1. This we have proved here. So this exact line is written. If the conditions are different in initial startup, and if it is annealed, if it was not annealed, no problem, just go ahead with the formula which we have derived earlier. But it is saying if it is annealed, if it is annealed. Okay, so now, so drawing stress is given by equation 7, that is sigma d k. There is no change in this. At limiting strain, maximum strain will be epsilon equal to epsilon star. We have put it here, the epsilon star n plus 1 and this. Now putting the value of sigma d, we know what will be the maximum value of sigma d max equal to k n to the power n. We will put here, and now we will cancel this k and k, and we will rearrange the terms. Okay, so rearranging will give efficiency term n plus 1 n to the power n. We will put bracket, and here it is n plus 1. So here it will be 1 upon n plus 1 equal to epsilon star. So this formula is given in the book exactly for this condition. Therefore, the maximum strain in annealed condition, because we are doing for annealed condition written in the book. So through this formula changes, putting those values given in the question, we have reached 9.26. So you also solve this. I have solved many times reaching 926. If there is any error, just please inform me through mail or in the comment box. So you have seen that according to the book, answer is given different. Okay, and the bone of contention point is annealed condition. Annealed condition, it is coming 0.926. That is different from the gate answer key provided and the explanation given in the gate NPTEL website. So there is a humble request. There means I am not proving my point to make me superior. Just as a student, there is a doubt in my mind which I was not able to solve. So it is a request that share this video as much as possible. And if you get a correct answer, only one will be correct. That gate and the book. Both can't be correct. So please do inform me if you get or reach your answer through discussing with your faculties in the coaching or in institute, and please do inform me. I will be um, greatly thankful to you for just solving this doubt. So I hope you enjoyed some concept, some different concept which is not given in many books. So let's meet next time with a new question with a new concept and waiting for the right answer for this question in the coming days. Okay, so have a nice day.